Hi, I'm Alix Paultre, and I'm the editor-in-chief of Electronic Component News. Today I have the great pleasure to have Alix Martinez. He's the product marketing manager for the Memory Products Division of Microchip Technologies. Today he wanted to tell me about their real-time clock family, a new set of devices that were created specifically for intermediate level engineering applications. So Alix, why don't you tell me a little bit about it? We all know the importance of real-time clocks and of timing in devices, but then your chipset, I believe, brings in the added functionality of addressability and low power standby and other facets that are very useful to the engineer.
Yes, well, thank you. We ended up talking to a lot of different customers, and we've been in the market for a long time. And so we looked at different products and different feature sets, and we found that there were certain features that customers were always using. So we decided, let's go ahead and look at certain products. Let's look at the features that would be beneficial, but would also provide the lowest cost and help your customers reduce component count.
So it wasn't a straight, this is too expensive, we're not going to do it. It was more a case of there are functions that we need, and we'll do that in the most cost-effective manner possible.
Yes, because there are a lot of the features that are in our first product here. We're already doing in some way or other. We might be offering it as a standalone device. It might be part of something that we're doing inside our PIC microcontrollers. And then we've had others that are just important. For example, accuracy. Accuracy is very important for real-time clocks. So that's why we made sure that we added in a digital trimming circuit.
Useful.
So it's very useful. So along other things, and one of the things that we've added in here is importance is battery switchover. Because how many times do you have a device that you lose power, and then the power comes back on, and now you have to reset the time?
Yeah, and you don't know when it went off, you don't know how long it's been off, you don't know anything about it.
You don't know anything like that. So with our device, we added in a battery switchover, so we can keep the clock running all the time. There's a backup battery, keep clocks running, and we also have a timestamp. So the timestamp, it'll tell you when you lose power, it'll tell you exactly when power was lost, and then the timestamp will also be logged again when power is restored.
So it's literally belt and suspenders. You've got backup power, but if it fails on you, you know when it happened, how long it's happened, all of the facets.
Yes, and that's important, for in refrigeration systems, perishable goods. How many times do you want to eat food that's been thawed out and refrozen, and now you want to cook it and then eat it?
Well, this is a good point. Or there are other applications where if the data is old, it's no longer valid data, or if the sensor readings are old, it's no longer valid information, or if it is, it only stays valid because you have the timestamp, which keeps it relevant.
Yes, that's why security, this is very important in security. The last thing you want to do, what happens if power goes out and you're monitoring a gate, and the gate, all of a sudden power goes out, you want to make sure that over a certain time frame that you know exactly when people, if they tried to sneak through, you knew exactly the time that your power was out.
That's a good point. Or talking about one of your other aspects, the addressability, if you have multiple devices, you can then poll which devices were on, which devices were off, and know exactly which device you were talking to.
Yes, because we made sure we put in, since we had memory, there's a E2 and SRAM in our device, but we also added in the 64-bit unique ID that can come pre-programmed with a MAC address. So for communications, anybody you want to communicate with, internet, wireless communication, Zigbee, Bluetooth, anything, you need a MAC address.
Right. Well, everyone keeps talking about the singularity, the ubiquitous computing, the whole issue. That needs addressable devices in order to function properly, because unless you can specifically address a specific device or a circuit or functionality set, you're basically fumbling around, aren't you?
Yes, that was one of the reasons why we added it in. And it's very difficult for customers to handle it this way if they're going to do their own programming, because if they're programming up a singular device, now it's an individual code for each system that they actually produce. It gets to be very cumbersome, and it's prone to errors. So when we do it at a higher level. We do it at a wafer level programming, which makes it very easy and very robust, and very few errors actually ever occur, if any.
Because it's programmed at the wafer level.
It's programmed at wafer level.
Very nice. Now I notice you have this little board here. What is this board? This is a development kit? Is it an evaluation board? What exactly does this board provide functionality for us?
Well, what Microchip does is we have all our development boards. We have PIC 18, Explorer, Explorer 16. We have a lot of different Explorer boards, and that's the bottom board, the big base board here. What we're doing to add to this is we've got in what we call our pigtail. And this pigtail board, it's a daughter board that plugs directly into this board here. See how it actually unplugs. And as you see, there's 3 different connectors to allow us to go ahead and plug into a lot of different microchip development boards.
So this is the actual board for the device, and then it plugs into your existing development kits and evaluation boards.
Yes, and one thing that we've done is we also, as you see here, we've included the battery backup. So there's a coin cell battery, you've got battery backup. So right now, if it was running, and I'd be backing up the power so I can unplug it, walk around, do whatever I wanted to do, plug it right back in. And here's a display here, so if I had this board running, I could actually go ahead and look at the time and see that it didn't lose a beat.
Excellent, excellent. And one of the important things when you're dealing with battery products are standby power.
Yes.
Right? What is the standby power on this device?
Well, here right now to operate on just operate off the backup power is less than 700 nanoamps. This will keep the clock running, and it'll also provide the SRAM data retention.
And if you want to be really belt and suspenders, you can always use the EEPROM.
Right. If it's something that has to be stored long term that you never lose, because even batteries, eventually if you forget to change your battery, eventually you're going to lose power. So what you want to do is store it in your E-squared. Then if you lose power, it's there, and it's there all the time.
Excellent. So, real-time clock, addressability, low standby power, wide array of communications capabilities.
Yes.
What else would you like to leave our audience with?
Well, one of the things that we've done here on our device, we want low power, and we've got the device operating at the lowest currents possible. Now, one of the things that we also offer is we still have applications that need 5 volts. So we have 5 volt capability on this device.
Oh, so that's very good. Useful to the engineer, especially for legacy devices that you want to improve the technology without necessarily rejiggering major aspects of the design, like the power bus.
Yes, and sometimes it's not even that. Sometimes high voltage is required. Some applications, they like the dynamic range of a 5 volt part. Their analog parts are 5 volts, and if they will operate down to 3 volts, they lose dynamic range. So they want 5 volts, so that means our device needs to operate on 5 volts.
That's very good. So we have a wide application area.
Yes.
A lot of mainstream functionality. And how much does this device cost?
And in 10K quantities, this device sells for 70 cents.
So under $1.
Under $1.
Very not bad. Well, hey, I really appreciate you taking the time to spend with us and tell us about the device. And I'd really like to thank all of you out there for taking the time to spend with us. So this is Alix Paultre with Alix Martinez,
yes,
saying thanks and goodbye.
Thank you.